Yeah, because I don't understand the. Can we do 37 and 39?
Is this 7? 12.7?
Yeah, 12.7, 37 and 39. Those were the two that you gave us last night. Which I barely did right now. Hang on, let me just fix something. Okay, 37 and 39.
Change it to spherical.
The second edition? Yeah. So then this, okay, so what's the, and then this is, so this is going to be yes, I think it's 5. But the projection is
Okay, how do we do this one? It says to evaluate by switching to spherical coordinates.
well, that's what we're arguing here.
Yeah, so how would you start? Yeah? I drew, sure, you drew the region. So what does this actually look like?
This is another ice cream. Well, actually, it's part of an ice cream.
Right, so we have actually x goes between 0 and 1.
Right, so first I drew the
Y goes between 0 and 1 minus x squared, which means in our xy plane, we actually have a quarter of a circle. We also have that z is between a cone and 2 minus x squared minus y squared, which is a sphere of radius radical 2. Right, so we have this guy. We have the sphere, we have the cone coming up. So we actually just want the part of this guy that's hovering above the xy plane, above the first octave. So that's it. So now we have to switch to spherical. So you should be able to tell me what is rho, what is theta, what is phi. Theta is 0 to pi over 2. Right, that we got from here. Yeah. What about phi?
phi is going to be 0 to pi over 4 on the kind of.
Again, it's the standard cone, 0 to pi over 4. Right, that's the angle that it makes, comes down in its cone rate. And then, how do you get the rho? From the sphere. It's measured from the origin to the outermost surface, which is going to be the sphere. So this is 0 to the radius of the sphere is actually radical 2, right?
Is rho always going to be the radius of what used to be
Rho is
r?
always the distance from the origin to the surface that you're considering.
Okay.
So then this guy is actually going to be equal to 0 to pi over 2, 0 to pi over 4, 0 to radical 2. And what's x?
Rho sine phi cosine theta
And this is rho sine
phi sine theta.
And then your dx dy dz becomes rho squared sine theta. So that's actually rho to the fourth sine cubed p and 1/2 sine 2. Okay, and these are all, the limits are constants and these guys don't really mix, so I can actually do 0 to pi over 2 of the sine 2 theta d theta times 0 to pi over 4 of sine cubed phi d phi times 0 to radical 2 root to the 4th d rho. I suppose from there it's easy, right? So this is just a substitution. This guy you're at is sine squared times sine, then change the sine squared to 1 minus cosine squared, or use sub for cosine squared, and that's just the power we're referring to. I assume continuing from there shouldn't be a problem. Right, but the first step was to draw the diagram so that we could figure things out, and what you actually did was you used the limits to set up your inequalities, right? So here I saw that the x went from 0 to 1, the y went from 0 to a radical 1 minus x squared, the z went from this to that. Right, so this was a cone that forms a sphere, the upper part of a sphere, and these guys I know is just like a part of a sphere.
Along this part, why is it 1 over slope and isn't it half a slope?
Because the x starts at 0 to 1, right? If the x had started at minus 1, then it's not. Right, so you only want the part of the upper semicircle where the x starts at 0. Yes. Come again?
Do I have to join the class to find out the row and take that?
It's one of the easier ways to do it.
I should find the c equals c squared is equal to x squared plus y squared equals 2 and find out the row. Then it's fine, right?
Yes, that's we actually use that here. That's how we know rho was this. Because this part tells us that it's x squared plus y squared plus z squared lesser.
I can use this method.
Yeah.
But in the test, do you require us to draw it back?
I might ask you to draw one. Yeah. But in the finals, they sometimes ask you to include a sketch. So yeah, you should know how to draw. The meaning you have the equation of the cone in rectangular and
Has nothing to do with
oh, so you mean if you had say p equals pi over 3, you want to know what kind of cone that is? Okay, so you know how a cone is represented by z equals, you know, it's rho
the lower half of the surface and under the higher half of the surface.
the easiest way to get this out. And are you given some sort of intersection, or you just want to find the general form of the intersection? Yeah, well, in general, that's sort of harder. It's like you have to just sort of think of.
Base 13.
And then, right, so you can do this guy. Because you know, in general, a cone would look like this. And so you would know that this guy is rho squared cosine squared. This would be a rho squared sine squared. Plug in the P, right, so you plug in, the rows would obviously cancel from both sides. You plug in the phi, so these guys are all constants. Right? And then you could either plug in for the A and the B and solve for the other guy. It's one of those trial by error things.
But so we should do it given the value of constant.
Yeah, in spherical it would be easy to have that. For a little bit more computational, going backwards. This? Oh, because this guy. This was the cone. You have z is equal to the radical of x squared plus y squared. Right? And you can actually plug in the formulas here, rho squared cosine phi, and plug in these and you can actually solve for the phi. Or you can realize that this gives you a circle of radius z. So you know the radius here is equal to the height. And you do that triangle that I was showing you. So you have this, and you solve the phi, you get part of it.
How do you find
the row gonna go from here.
39.
So this is fine. The row gonna range from this point to this point. So this is fine.
I have another question.
Yeah.
Again, how did you get the 5 or 4?
From this point to the angle is here.
This is the equation of the cone. You can just either plug in all the values you know in sphere. Rho cosine phi, rho sine phi, sine theta, cosine theta, rho sine phi, sine theta. You can actually solve for phi. Or it comes from this triangle. There are several ways. We talked about that.
Now we'll see the answer. I got it. No. And you've got like
Okay, how about this one?
it's a mess. Okay, we know it's a circle in the XY plane. It's a circle radius.
Right.
The sphere is a radius of 2. Right. It goes from 0, negative, which means theta goes from 0 to 2 pi.
That's your region.
Right. And then that's what we were just arguing about. I got phi.
Yeah, but what is
But-
this part?
Oh, that one? It's a mess. That is x squared plus y squared plus z minus 2 squared is less than or equal to 4, and that whole thing is to the 3/2.
So if you have this, right? We have 2 plus.
And then I set that, oh, I didn't do it like that. I then set that equal to rho squared to the 3/2.
You're thinking too complicated. What kind of figure is this?
A sphere.
You should.
It's a good point. Thank you. It's a sphere.
It's a sphere. How do you know it's a sphere? Well,
Magic.
you can subtract 2 from both sides. Get z minus 2 between this.
I wrote
That.
16 and knew it was a sphere.
So which side is the upper part of a sphere? This is actually giving you x squared plus y squared plus z minus
2 squared
equals
equals 4. And that whole thing goes to the 3/2.
no, the thing is too complicated. We're only setting up the region of integration.
Well,
So
this
how would
is,
you graph that? What are we looking at?
we're looking at z starts on 2.
0, 0, and 2.
Yeah. It's a sphere radius 2 that's centered around 0, 0, 2.
So it's sitting on top of that guy, right?
Right.
And we have
And that radius is 2.
right, which is going to project down. Right, that's sort of what you're looking at. Right, it's just a sphere.
Right.
Okay. So now how do you get to the row? So now
Well, rho actually is easy. I just set that equals to rho squared. That whole thing to the 3/2 equals to rho squared to the 3/2, and it got rho over 3, rho to the rho cubed. And then I set, oh, rho is less than or equal to 4 cosine of phi.
I'm not sure.
You put the x squared plus y squared plus z minus 2 squared into the sphere column. So
Yeah,
x,
so you plug in rows, blah, blah, blah.
Yeah.
blah, blah, blah.
Yeah, and what did you end up with?
You got the rho equals 4
Cosine
cosine.
phi.
By plugging in x equals rho sine phi cosine theta, y equals rho sine phi sine theta, z equals rho
Cosine phi.
into okay. And so you know that rho is actually going from 0
It's
to that
1 sphere.
because it's measured from here to the outer part of the right? So what is your phi?
Well, that's where we're having an argument.
And your theta is
0 to pi to 2 pi.
Okay, so what's your phi?
Well, mine is pi over 2. Oh, you changed it now? Okay, yeah.
No change.
0 to pi over 2.
Pi over 2.
So how can you
What's that?
find?
Well, how did you find it? Because we all found it very different ways.
Can you just show how do you find it?
I drew a picture, and I based it on the picture.
Well,
But I
yeah,
think that
you
was
can sort
kind
of
of
look
wrong.
at the picture and tell, right? Because it's sitting above the xy plane.
Right.
So you really want to cover everything from the positive z right down to the xy plane,
Right.
which
How
is
about
0 to pi
without
over
the
2.
graph?
Huh?
How about without the graph? How can you find the c?
If you don't have a picture, how would you find it? Like,
Okay.
say I was
The computer,
totally.
how are we supposed to compute
don't have the picture.
Well, that's going to be,
I couldn't draw to save my life.
you're going to need some geometry to help you because you probably use right triangles to do that.
Okay, so
Right, you're going to have this, if you look at this as just the x, y plane, and pretend this is the sphere sitting up there, then you're going to have this guy coming here. That's going to be your row. You form a right triangle here, and you're going to try to figure out the feet.
because what I did was I just found exactly at radius 2 in the sphere. I drew a point, and then I made that from the origin to that point my row, and I calculated with a right triangle, and that's how I got pi over 2.
Yeah, that's a more specific way of doing this. You could do it that way too.
So that was right? You wouldn't grade me 0? Are you sure? Say it now on camera.
Well, I have to really look at what you did. I just sort of see from the picture. This thing is, I need everything above the XY plane.
Okay.
And I already know a formula for the row.
If I set it for pi over 4, then I'd only get half the sphere, correct?
Yes, if you set it for pi over 4, you get the ice cream cone that hits you. You get an ice cream cone.
Okay.
Right? And you can see that as long as your phi is below 2 pi, you'd always get a part of the sphere. You'd always get just a fatter ice cream cone until you sort of get down to it. Right? You always have to be increasing the angle because there's always going to be a part of the sphere below it. You have to go all the way down to
pi over
2
4, pi
to
over
get the whole
6.
sphere.
Okay.
Yeah. From the picture, it's easier. That's one of the reasons why I like drawing pictures.
I didn't know how I got it. I just got it.
But yeah, with that, we now know that this would just be 0 to 2 pi, this would be 0 to pi over 2, this would be 0 to 4 cosine phi. This guy here is rho squared to the half power, so that's just rho cubed. So in total, we have rho to the 5th sine of phi.
Yes. And then the square sine plus.
Okay, review problems.
Can we do spring 2005, number 10? Do you want it on the iPad? Oh, she's got a printed. Can I have my iPad back?
Spring 05, number 2.
Number 10.
Number 10. Find the mass of the hemisphere of radius 5. So we have number 10. Okay, so here's the hemisphere. The radius is 5. I want to find the mass of that guy, given that the density is equal to the square of the distance from the center. So how do you measure the distance from the center of a sphere?
No.
Distance from the center of a sphere is what?
I'm not understanding the question.
So here we know rho of x, y, z. It's equal to density of phi. You just think of it as the radius. Alright, so the distance of the point xyz from the center of the circle is just the distance of xyz from the point 0, 0, 0, which you just use the distance formula with xyz and 0, 0, 0. So that's actually a rho. And now they want us to find the center of this here. So what coordinate system do you use? Spherical seems to be really nice. Here you can just say rho is 0 to 5, b is 0 to pi over 2, theta is 0 to 2 pi, and the mass is given by the triple integral over your solid of the density function. Don't confuse this row with that row. They're actually two different rows. dv, which in this case is going to be 0 to 2 pi, 0 to pi over 2, 0 to 5 of this guy, which is rho squared, it's square rooted, so that's just rho times.
So the top row is the density, correct?
This is the density function.
That's the density.
Yeah. Which,
And the other row is...
to avoid confusion, I can call this guy over. I can call this something different.
Well, I was just going to say, because when you put it in the integral, you cannot put rho 3, it's cubed then, correct?
Yeah. You call it by a different name. It's really different from the row here. So you can call it D or whatever you want.
So if you call it D, because I'm looking at it, I'm thinking you can't really
Yeah, so you
combine
can't really
it.
have rho on both sides. Yeah,
Yeah.
it wasn't the same. It was just an
Okay.
inconvenient scenario of notation. Yeah, but that would be the integral, which is not that bad. That's constant limits on the
The question says that Z equals the square distance from the center.
Oh, so then it's just this, and so this is just that. Yeah.
Okay. That's the density squared.
Yes, this is the distance from the center, and it's the square
I
of the
meant in
distance.
this over here. You didn't change that to D.
No, because the square root cancels the square, so I just have this.
No,
which
I'm
is
not
rho
talking about
squared.
that one. That one. You have rho and rho. Is it density and rho, or are they both rho?
No, they're both the rho. Like there's no rho for density. This is density. I'm calling it this.
Okay.
This is the dV,
That was my question.
and then this is from that.
Okay.
Yeah. There's a when you go to spherical, there's an automatic rho square sign phi. Call it.
Right. I was just wondering which row the first row squared was.
Yeah.
If that
This
was
is referring
density.
to that.
Okay.
Can
That's
you
that.
say why the P is from 0 to pi over 2?
Can't use the same letter.
Because it's covering from, remember it opens from the positive z-axis down.
But
Right.
isn't it supposed to go that way?
It doesn't matter where you. Or even if over here you measure positive z-axis down, it's still pi over 2. You're still going from a 90-degree axis, right? This thing is above the xy plane, so it's always from the positive z-axis to the xy plane. That's a pi over 2 angle rate.
Oh,
For B, I didn't ask a question like that because we're not something elementary, but for your own education, I can do it. It says use the Riemann sum to approximate this guy, where it's 0 to 4, 0 to 4 of x squared and x dy. Use your delta x equals your delta y equals 2. This means you're in the xy plane, you're going from 0 to 4 on the x and the y, so that you're on this rectangle. Your delta x just tell you how many sections you break up the x into, so it's just 2. That's the change in x. And your delta y is just the change in y. So really you want to break this up into 4 rectangles. And then it says use the midpoint rule, which means you take the middle of each rectangle. Right, so the point here. So this would be the point 1, comma 1. This would be the point 1, comma 3. This would be the point 3, comma 1. This would be the point 3, comma 3. Right. And so this integral 0 to 4, 0 to 4 of x squared dx dy, where the x squared, you think of that guy as your f of xy. This is approximately equal to the Riemann sum with 4 dissections, which is equal to delta A times f of 1, 1 plus f of 3, 1 plus f of 1, 3 plus f of 3, 3. And your delta A is just the area of this rectangle, which is 4. So that's just 4 times, you square the xy, so it's 1 squared plus 3 squared plus 1 squared plus 3 squared. 4, 2 9 to 18, that's and then it says, how does your approximation differ from the exact value? Well, you'd have to actually find the exact value. So this is the approximation. For the exact value, you actually just compute this integral. Which is just equal to 0 to 4, you have x cubed over 3 between 0 and 4, y have 0 to 4, 4 cubed over 3, y. So this is just so the difference. Whatever that is. Okay, other questions from 205? Any more from Spring 205? From the same final? Find the volume of the region bounded by blah, 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 blah.
Which one is it?
Spring 2005. We're doing question 5 now. X squared, what does 4 minus x squared look like?
Upside down parabola on the y-axis.
Upside down.
Parabolic
Yes.
cylinder.
It's a parabolic cylinder, right? Because it runs along the y.
Yeah.
Right? And then there's y equals x, which is just a line, a plane that slices through that at that angle. And then y equals 0, which is the wall here. And then z equals 0, which is the xy. So this is what you do. Right, just that little wedge right there.
Why not the other side?
Come again?
Why not the other side of y equals x? It's still bounded by y equals 0.
But it's not
Yes, but
bounded by
it's
y
not bounded by y equals 0.
Zero.
Y equals 0 is the xz plane. Right, which is the back wall.
Boundary in the other direction.
Meaning something but the other except like.
I mean, y equals the plane.
Oh, do you mean the back part?
Yeah.
Well, then that would give you another slice. Did it say? Four minus x squared. X equals y.
It'd give you the same volume either way.
What should we have just?
Y equals 0.
Wouldn't it give you the same volume?
And x equals. Well, yes, over here would be symmetric to over here. But the question
Yeah,
is,
so-
would that be included?
So if we gave you a negative answer or a positive answer,
You
But then-
won't get a negative answer. It's going to be above the xy equal.
yeah.
And it's a volume. It's supposed to be positive.
If you need x equals 0 as a bound
Yeah, they never gave me the x equals 0 requirement.
No, but I think in the solution, we take both the sides on it.
Yeah. You include both the sides. There was another problem where they didn't, but yeah, there's another wedge on this side towards the negative part.
We have to take the negative part.
Yeah.
Right?
The answer is 4, which is the first octave. The other part is 8.
The other part is what? It never said the first octave.
No, I know. If you include the back part, then the answer is 8. But the solution says that it's 4, so they just took the first octave.
Yeah, but the question didn't really say that.
It said it's bounded by the plane y equals 0, so only consider the first one.
Yeah.
We have the same problem, yeah.
But y equals 0 is also the same on the other side.
But z equals 0 to
Yeah.
But if it was on the other side, then it would have a negative y value for the x as x equals
You're
y.
talking like over here. Like
Yeah, but
when
that's
you're in
negative
this
y
region.
on that side, isn't it? Wouldn't that be a negative y value?
It would give you a negative y value.
So if it says y equals 0, then we shouldn't even go there.
But the thing is, this is also bounded by y equals x. This is, the top is z equals this.
you say that y equals
Z
0
equals
and z
0.
equals 0, you can never be
And
negative.
then,
Right.
yeah, you wouldn't, this part wouldn't be bounded.
Right, because if it says y equals 0, the y part is negative on that side.
So I know you have this
Look at
boundary,
it
you
in
have
the
this
XY.
boundary, you have that boundary.
If I bring the line back here, my y is 0, or below 0, my y is negative
But then also there has to be more time. Like it can't be.
2. But it's bounded by y equals 0.
Not the sum of bounded by y. No. If it's like that one. You see, like if it was like y squared, equals to
I think the
then.
question is poorly phrased.
Maybe the question is wrong.
I think if you give a question like this on the exam, everybody will.
I think the way this is phrased is you'd have to take both sides. I know there was a similar question where you only took one side, but the way this is phrased, I think you need both. Because if you look at this part here, it's actually bounded by all those curves also, right? There's your y equals 0. There's your y equals x. And then this outer part here comes from that part of the parabola cutting down that side. So this region is also bounded by everything listed there. So it would count. I mean, we'd have to add in the first octave, or such that on the right side of the y-axis, on the right side of the xz thing, or something like that. The way this is phrased, you'd actually need both sides.
Okay.
But both sides they're actually symmetric, so you can just compute the first side and then double it. You'd actually need both here. So volume would be 2 times the triple integral of 1 dv, where this is the region in first octave. And so, how would you actually set that guy up?
So for x, it's 0
In the xy plane, you just have y equals x. You have this would cut 2. That would be 2. You have this. So you can do x from 0 to 2. Y goes from 0 up to
X,
x. Your z goes from 0 up to the
4 minus x squared.
and someone said the answer was 2. Yeah. I don't see why you would leave off the back part. Nothing really says it. Right, you need additional information to leave off the back. Other questions on Spring 2005? But yeah, if I'm answering a question like that, I'd be very specific. I only want the first octave. I only want over here. I only want over there. Any more Spring 2005 questions? Okay, questions from another final?
Number
Fall
10
2010.
number 1.
and number 10A.
On fall 2010 as well?
Yes. Yeah, we didn't sleep last night.
So this is fall 2010. And you said number 10, right?
I said
11.
number 10, she said 11.
Oh, we'll do both. Let's do 10 first. Sketch the portion of the paraboloid that lies above the plane, blah, and by its surface area. Okay. So you see, this one specifically asks you to sketch, and usually, typically with the area problems, this is how they act. They ask you to sketch something first, then find the area, and I probably do the same. So I want the area of z equals 9 minus x squared minus y squared above z equals 5. What does the first guy look like? It's not a cone.
No, it's a sphere with a radius of 3.
It's not a sphere either.
Oh no, it's a paraboloid.
It's a paraboloid. It starts at 9, down like that.
I know. It's because the z is not squared.
Take a cross product. No, it's a sphere. No, it's not a sphere. Right? Z would have to be squared in order to be a sphere, and to make it a cone, Z would have to be a minus squared.
Okay.
Or,
Square root.
Z would have to be so
Okay.
now what?
That might solve the problem. I think that just solves my problem.
Right, so here's 9, z equals 5, you want the part above that, right? So z equals 5 is obviously going to be below that. So you're going to take a plane and you're going to slice this off,
Okay.
right? So really you're looking just at the cap here. You want the area of that cap. But you're going to have to figure out what the region of projection is. D. So what is your D actually?
It's the circle with the radius.
Right, it's the intersection. You plug in z equals 5 into here, and you'd actually get the equation x squared plus y squared equals 4. Right, so that's the circle radius 2. So now, I know z, take that to be my f of xy, which is 9 minus x squared minus y squared. I'm gonna need the partials. Partial with respect to x is minus 2 x with respect to y is minus 2y. And so I know that the area is actually the double integral over d of the radical of fx squared plus fy squared plus 1a. That would be double integral of d over 4x squared plus y squared plus 1a, which it's easy to switch the polar now. So that's just equal to 0 to 2 pi 0 to 2 of the radical of 4r squared r dr. And then you just do a u sub, right? Equals 4r squared. And what if I said, find the area of this that's above that in the first octave?
Wait,
How would
say that
change
again,
the
find
problem?
the area.
Just change the for the like if they have 2 pi 2.
Yeah, so if I said that, right? Exactly the same question, but I added in the first octave to the end. The only thing that would
Just
change
change it 0
is
to pi.
the theta, 0 to pi over 2, right? But everything else would be the same. So
So that would be 0 to pi over 2?
pi over 2, yes.
Yeah, okay.
Okay. What if I said all of that, but to the right of the xz plane? How would that change the problem?
What's your up and down?
Exactly the same problem, but I added to the right of the xz plane.
So it's gonna be
0
That
to
would
pi.
be 0 to pi.
What if I said to the left of the yz plane?
That would be 0 to pi to pi over
pi over
2.
2.
Negative pi over 2
To
to
the
a
pi.
positive pi over 2. Yep. Okay. But everything else would be the same. So, but the limits would change. Okay. Other questions? You 11, right? 11. Let me see. Mr. Cup radius 3 is filled to the bottom into the layer of chocolate ice cream, and into with vanilla ice cream, top into with strawberry.
Sounds like a plan.
Okay, so I would make my cup. I see what you. So the first thing is we want to know a nice way to model this cup. But it's hemispherical, so I would probably do like this,
I have a question.
where the top is the XY plane. Yeah.
Would you give these type of questions?
He gives murder mystery
It's
questions.
ice cream. How nice can you be with the question? Ice cream. Everyone loves ice cream. Okay, so you split this
hard.
guy into 3
Why do you
layers.
give such a hard question?
What?
Hard.
So if you're looking at the XY plane here, your cup would look like this, and then there will be 1 in each side. So this would be where 3 is, this would be minus 3, this would be minus 2, this would be minus 1. And then I know. So here's chocolate. Here's vanilla. Here's strawberry.
But the densities are uniform.
Uniform density means it's a constant. Right, so density, let me call it D, is K, a constant. Alright, so I have a constant density. Now, which flavor contains the center of mass of the ice cream? So how would you do that? Find Z bar, right?
Oh, I would eat ice cream.
You'd eat ice cream until it tips over. Find Z bar is what you want to do. If your answer for Z bar is between 0 and -1, then it's in the strawberry. If Z is between -1 and -2, then it's in
Vanilla.
it's in the vanilla. And if your Z is between -2, well, this can be less than or equal to me, it doesn't matter. Then it's in chocolate. So basically that's all you have to do. Find the Z bar. Yeah.
Should it be -1 is less than or equal to C bar less than or equal to 0?
Come again?
The inequality for if it's
Yes.
yeah.
It's the other one. And I think these are the other way as well.
I think so too.
0, -1, -2, -1, -3, -2. Yeah, so basically that's all you're doing, finding the Z bar, which means you need to find the M. So your M is just going to be the triple integral over this cup of K dV. How would you set up this integral? Price circle. And what would the limits be? Theta?
0 to 2
0 to 2 pi. What about the phi? Pi over 2 to pi. And then the rho is the radius, which we are told is 3. So it's just 0 to 3 of k rho squared sine d rho. So you get that and you get n. And so your Z bar your Z bar would be 1 over whatever answer you got there times the triple integral of 0 to 2 pi, pi over 2 to pi, 0 to 3 of Z times K times rho squared sine. And the K, there's going to be a K in the M that's going to cancel this K. So then you just have to integrate that. But what about the Z? How do we deal with that? You have to change it to rho cosine. So this is just going to be 1 over n rho cosine. So then you're going to find that answer, and then based on its value, you can tell what flavor it falls in. Other questions? Oh, whenever you're given a solid 3D object, it means that you want the triple integral. Right, so the double integral shows up when they say something like it has negligible thickness, right? Or it's a lamina of something that covers this 2D region. So
Think of it as
yeah, it's basically like a plane.
Can we do fall 2005, number 10?
Yeah, fall 2005. Oh, I just set it up that way. I mean, it's a cup, so it's usually this way. So. Yeah, but then your chocolate would be in the bottom. I mean, your cup would be upside down. Your ice cream's gonna fall out. You could do that, but you rearrange the C, the S, and the V.
We could pretend there's no gravity.
The C would be between positive 2 and 3, positive 1 and 2, 0 and positive 1. Yeah, I just have it like that because it's a couple. Called
Oh God.
number what?
Number 10.
Okay, change the following triple integral to cylindrical coordinates, then to spherical coordinates, and evaluate one of the three. One of the three. So change to cylindrical and evaluate. And the given integral is -3 to 3 9 minus x squared 9 minus x squared 9 minus x squared. Oh, sorry, that's 0. What's that?
The first, it's a sphere with a radius of 3.
Is it a sphere of radius 3?
No, it's half a sphere of radius 3.
Half a sphere. The upper sphere of radius 3.
I was very tired. Sorry. 0 for negative 9.
So we're like,
It was
like
early.
near the
I
matrix
was
here,
tired.
ones and zeros, and then we see a picture. Yeah, that is the upper hemisphere. That's what it looks like.
Right.
Right? Because you can actually do x goes between -3 and 3. Your y would go between -9 minus x squared and 9 minus x squared. So that already gives you what it looks like in the two-dimensional sphere. Right? That's just
Right.
a circle of radius 3.
And they're all centered
Then
around
we
the
said that
origin.
z go between 0 and 9 minus x squared minus y squared. Well, this part is the same as saying x squared plus y squared plus z squared is less than or equal to 9. It's a sphere of radius.
Right.
But the 0 tells us that we cut off the bottom. We don't want negatives. Right, so this is actually looking at the upper hemisphere. Now once you know the region you're integrating, setting up the limits in cylindrical and in spherical should not be so bad. So we know we're just doing the upper hemisphere of radius 3. So what's the cylindrical setup?
The cylindrical is between 0 and 2 pi for theta. And then between 0 and 3 for r.
That is between 0 and what?
0 and the square root of 9 minus r squared.
Right. Then you have the z. Then you have r squared plus z squared. Then you have r dz
R
r.
d theta. It was the spherical that I was having problems with.
How do you evaluate that?
Well, you need to use substitution, right?
For what?
r squared plus z squared.
You're doing dz first, so you do a u substitution for the z, right? So u equals r squared plus z squared, and your du would be 2z dz. So you take 1/2 du dz dz, right? And then you do a u substitution.
Right.
And you can
No.
you do it that way. Yeah. So now if we do the spherical,
So the spherical rho is 3,
rho is 0 to 3.
0, right, 0 to 3. And then theta is still 0 to 2 pi.
Right, the theta here and the theta there are exactly the same.
Right. But the phi is where I got stuck.
Well,
Yeah,
if we want to cover this whole solid,
Yeah.
and we want to span an angle that goes from here and stops when the solid stops, what angle would you have to go through?
Pi over 2.
Pi over
Yeah.
2, right? You start with 0 here, and it hits pi over 2 by the time it hits the xy. So this is 0 to pi over 2. And then in the actual function would be z, which is rho cosine phi times x squared plus y squared plus z squared is rho squared. Take the square root of that, you get rho, since rho is positive. And then this is rho squared sine rho. And so you would actually have here 0 to 2 pi, 0 to pi over 2, 0 to 3, of rho to the 4th cosine phi. And personally, I would have evaluated this one for part B. Right, I spare myself some nasty u substitutions. A lot of potential mistakes in it. Although after the first substitution, this actually ends up doing this. I think you'd end up integrating a constant times r. Yeah, so, other questions? Call 2010 questions?
This is where I got.
Call 2011. Yeah. What problem? Mass of the region. here we also have the rho over density. Let's call it d is equal to z. So it's equal to the distance from the xy plane. Okay, so how would we do this one? The mass is just the triple integral over the region of the density dV. So we actually know what r is. That's just 0 to 2 plus 2 cosine theta. The z is just 0 to 2. D is just z. And what else are we doing? So this is times r dz dr dθ. What's the theta value?
It goes from 0 to pi.
It is 0 to 2 pi.
But how do you know it stops at 2 pi?
Because you'd have to revolve around a full circle in the xy plane. You have an object that's circling the
You
origin.
know, it's like a
Okay.
hard thing.
It looks like it sort of looks like a
Right,
arc. Yes.
right.
So
I know.
if you graph r equals 2 plus 2 cosine theta, move up 2 down to 2 is 2, so it's 4 and 0. Pi over 2 pi, 3 pi over 2, 2 pi. This would be just like that.
Right.
So this is 2, and that's 0, which means if you go to the xy plane to graph this, you have a circle of radius 2, you have a circle of radius 4. When your theta equals 0, you're on this circle. When your pi over 2 brings you to this circle, pi brings you to 0, 3 pi over 2 brings you to that circle. So it's a sideways arc. And so 0 to 2 pi covers everything.
Right.
Yeah, that's actually not a bad idea. Again, do not be tempted to actually evaluate the outsides and put the 2 pi like we usually do here, because it won't work because the theta is on the limits here. So that would be a problem. So you'd have to actually evaluate this before you can worry about the d theta. So just be aware of that. Other questions? Well, if you realize that this was actually, it's actually not like a loop or anything, that's fine. So you know you're away from the origin, you touch the origin, then you go away from it. I don't know if you can imagine. I mean, some intuition from calc2 will be okay if you don't go this way. Yes. So that was a fun one. It's that you actually have an object that looks like that's so sweet.
It's like a half of chocolate.
It's like a candy heart. That's 2 inches thick.
The Walmart box.
2 millimeters. Yeah. Other questions? Okay. I guess we can take a break and then go upstairs.